In this lesson, we're going to talk about ions and some exceptions when we're talking about electron configuration. So first we're going to talk about the octet rule. So the octet rule states that atoms will gain or lose electrons to have 8 valence electrons. So we have two examples here. So the first one is fluorine. Fluorine has 7 valence electrons. So to get 8, fluorine is going to gain 1 valence electron in its outer shell. Okay. Now, a neutral fluorine atom has 9 electrons. So if it gains another electron, it's now going to have 10 electrons, 9 protons, and in that case, it's going to have a charge of -1. In my second example here, I only have 1 valence electron for sodium. Now, it's a lot easier for an atom to lose that 1 valence electron. It's kind of like peeling an onion. If you peel away this outer shell here, there is below it a full outer shell below. So again, take a look here. We have 1, 2, 3 rings, 3 orbitals. And when we peel away this outer shell, we're left with 1, 2 orbitals. And the second orbital has a full shell of valence electrons. Now, a neutral sodium atom has 11 protons. So if it, 11 protons and 11 electrons. If it loses an electron, it now has 1 more proton than electron. So it's going to end up with a charge of +1. Okay, so here's an example. It says predict the charge of oxygen when it ionizes. Write the electron configuration of the oxygen atom and its ion. And then which noble gas has the same electron configuration as the oxygen ion? So the first thing we're going to do is we're going to look at the periodic table. Okay, so oxygen on the periodic table is right here. Oxygen is in group 6A, so it's going to have 6 valence electrons. To get to 8 valence electrons, it needs to gain 1, 2 valence electrons. So if it's gaining 2 valence electrons, it's going to have a charge of -2. Okay, so oxygen will have a charge of -2. It says write the electron configuration for the oxygen atom and its ion. So oxygen normally, its electron configuration is 1s2, 2s2, 2p4. Okay, so it has 8 total electrons. That's a neutral oxygen atom. Now the ion has 2 more electrons. Okay, so the ion, when we have a charge of -2, we just need to add 2 more electrons to this. So its electron configuration will be 1s2, 2s2, and then instead of 4, it's going to be 2p6 because it has a total of 10 electrons. And then it says which noble gas has the same electron configuration as the oxygen ion. So let's pull up the periodic table again. So oxygen is here. 8 valence electrons will give us 1, 2. It's going to be the same as neon. So the oxygen atom has 8. The oxygen ion has 10. So it's going to have the same electron configuration as the noble gas neon. Isoelectric is a term used when you have 2 species that have the same electron configuration. So the examples would be neon and oxygen with a -2 charge. They're isoelectric. They both have 10 total electrons. So here's another example. It says write 5 species that are isoelectric to calcium with a +2. So let's take a look at the periodic table. Okay, so calcium with a +2, so here's normal calcium right here. Calcium with a +2 will have 2 less electrons. So if we go back 2 on the periodic table, that'll put us right here at argon. So argon is isoelectric to that calcium with a +2 charge. So we want to find 4 other ions that we can write that'll also have 18 electrons. So let's take a look at chlorine. Chlorine normally has 17 electrons. To write chlorine with one more electron, it'll be chlorine with a -1 charge. Sulfur normally has 16 electrons. To write sulfur with two more electrons for a total of 18, it'll be sulfur with a -2 charge. Phosphorus normally has 15. To write phosphorus with 18 electrons, it'll be phosphorus with a -3 charge. And let's do one more. Potassium has 19 electrons. To write potassium with one less electron, it'll be potassium K with a +1 charge. Okay, there are two exceptions that we need to know about, and those are chromium and copper. Okay, if we were writing out the electron configuration for chromium, we go to our periodic table, it's going to be in noble gas configuration, argon, and then it is going to be 4s2, and then 3d4. Okay, same thing for copper. If we write out copper, it's going to be argon, 4s2, and it's got a few more electrons, 3d9. Now, what ends up happening with these two exceptions, one electron from the s orbital will move over and join the d orbital. So the actual electron configuration for chromium is going to be argon, 4s1, it should be a 1, 3d5, and then for copper it'll be argon, 4s1, 3d10. Okay, so we end up filling half the d orbital with chromium, and we completely fill out the d orbital with copper. So the two rules for these exceptions are half-filled orbitals are more stable than partially filled orbitals in the case of chromium, and for copper, completely filled orbitals are more stable than partially filled orbitals.